Okay, let's talk about electrochemistry. So electrochemistry is the chemistry involved in the transfer of electrons. When we were talking about acid and base chemistry, we were talking about the transfer of hydrogens. Now in electrochemistry, we're talking about what are called redox reactions or oxidation reduction reactions. Oxidation reduction reactions. They're sometimes abbreviated redox reactions. And they are two half reactions. They're called two half reactions. There's the oxidation part and there's the reduction part. And what's happening in these two half reactions are the transfer of an electron. So remember, electrons are one of the three subatomic particles. Its mass is negligible. It's about 2,000 times smaller or 2,000 times less mass than a proton or a neutron. So we say the mass of an electron is negligible, but it has a charge of -1. So when we're gaining or losing electrons, we are also affecting the charge. So let's break these two half reactions down. So the first half reaction is called the oxidation half reaction. And oxidation is when you lose an electron. It increases the oxidation number. We haven't talked about that yet, but we will talk about oxidation numbers and assigning oxidation numbers. The other part of the half reaction is the reduction half reaction. And a reduction half reaction, a reduction reaction is where you gain an electron. So this is a little bit counterintuitive because you would think if you're reducing something, you would be losing that thing, but that thing that we're losing here are electrons. And electrons are negatively charged. So when you are gaining electrons, you are reducing the oxidation number. Because you are gaining something that is negatively charged. Something else with the terminology here, there's oxidation and reduction half reactions. There's also oxidation and reduction agents. So an oxidizing, I'll say oxidizing, not oxidation. An oxidizing agent oxidizes another species. But the oxidizing agent itself is reduced. And then the opposite is true for a reducing agent. A reducing agent reduces another species, but itself is oxidized. Depending on where and when you took the second quarter of general chemistry, you may or may not have talked about oxidation reduction reactions. It's covered in chapter 8 of your textbook, chapter 8, section 6. I think it's page 332. That's from the second edition of this textbook. So depending on if you're using a different edition of the textbook, it might be in a little different location. But if you have never seen anything about redox reactions before, I'm going to work through it in this quarter's information, but there's also more for you when redox reactions were first introduced in chapter 8. And then we're going to apply it to acid and base chemistry and electrochemistry in chapter 17, which we're working in right now. Okay, so this is all gaining and losing electrons. So similar to acids and bases where we're gaining and losing hydrogens, in redox reactions, we're transferring electrons. So the way that we work through redox reactions is we assign oxidation numbers to atoms or ions to be able to determine if a species is being oxidized or reduced. So we assign oxidation numbers, and there's no such thing as a reduction number. It's just all oxidation numbers that we use for both the oxidation and the reduction sides of these reactions. We assign oxidation numbers to atoms and ions to be able to determine if a species is being oxidized or reduced. And then what we're going to do later is we are going to balance redox reactions in an acidic or basic condition. Well, we're going to balance redox reactions. We'll talk about just balancing regular neutral condition redox reactions first, and then later we'll talk about balancing redox reactions in acidic or basic conditions. Okay, so let's talk about how we assign oxidation numbers. So, the oxidation number of an atom is 0. So for example, solid iron, which is an atom, would have an oxidation number of 0. The oxidation number of a monatomic ion is the charge of that ion. Monatomic, meaning one atom. So for example, chlorine would have an oxidation number of -1, the chloride ion. The sodium ion would have a charge of +1. What's another example? Let's say the magnesium ion would have an oxidation number of +2. So whatever the charge of the ion is, that is the value of the oxidation number. Hydrogen, oxidation number is always +1. A compound, the sum of the oxidation numbers is neutral. For a neutral compound. So for example, NaCl is a neutral compound. The sodium has an oxidation number of +1. The chlorine has an oxidation number of -1 for a sum of 0. A neutral compound will always be made up of pieces of oxidation numbers that will sum up to 0. Polyatomic ions will have an oxidation number sum equal to the charge of the polyatomic ion. So we haven't covered this yet, but for example, nitrate has a charge of -3. So oxygen has an oxidation number of -2, and I have 3 of them, so that's -6. That means that this nitrogen must have an oxidation number of +5. +5 plus -6 is -1. We haven't covered this yet. I will teach you how to do this. But just as an example, the polyatomic ion has a sum of equal to the charge on that polyatomic ion. And then the last thing is that transition metals can have multiple ions, so they can have multiple oxidation numbers. So therefore, they can have multiple oxidation numbers. So you need to determine the oxidation number based on what it is in a compound with. So these are the rules for assigning oxidation numbers. Again, this was initially covered in a previous quarter back in Chapter 8. Feel free to revisit that if you want more information. I will teach this in the next few videos as if you haven't covered any of that other material. So I'll go through examples of assigning oxidation numbers and working through examples of each of these in upcoming videos.